Hi everyone, you're all very welcome to this webinar on the topic of how IBM Power Systems can use the cloud. My name is Adrian Kelly and I'm the Sales and Marketing Director of DNA IT Solutions. I'm joined this morning by a panel of experts from IBM to discuss the latest developments around the IBM Power Systems, and in particular to look at how Power Systems have a very strong future roadmap in the cloud. And regardless of what version of Power you're currently using today, there is a strong partner channel and ecosystem that is now available for you to take advantage of. And we're going to discuss how that could work and some of the developments and some of the new announcements around it. So my guests are David Spurway. David is an IBM Power Systems architect. James McKay, who's a global systems architect also with IBM Cloud. And Noel Crawford, who's the IBM Technology Partner Sales Leader in Ireland. And all-round IBM Cloud guru, it has to be said. So as we go through the session, guys, please send any questions you have using the questions facility there. Just send them on to us as we go along. Anything at all comes into your head, and we'll have a chat about them at the end of the session. And yeah, I hope you find the session useful. To kick off, just for those of you who don't already know who DNA are, I suppose we would sum ourselves up as DNA are a cloud managed services provider, or cloud centric managed services provider, I guess we'd say. We're very much into managed cloud services and managed security services. So I want to just, I suppose, give us a very brief introduction in terms of who we are. Hopefully you can all see my screen there. So I guess it's where do we fit in with all of this is what we want to really talk about. Obviously the Power System is an IBM system, but where do DNA fit? So we're a partner, as I said, of IBM. We're one of IBM's sort of primary cloud partners in the country. We're very much driven by quality standards and excellence in terms of our approach, and security by design. Not going to go into a major introduction of us all here, but I suppose just to demonstrate, we have a very broad range of customers, from quite a diverse, from multinational companies to local industries and charities and not-for-profits and everything in between. We've a typical, very diverse customer base. We would provide a full managed IT service across a lot of different headings, from cloud to security and more traditional managed IT services. We work with all the major vendors and the usual suspects, but we have chosen IBM strategically as a cloud partner, and we've done that for many reasons. Some of the key ones really being here that attracted us to the IBM Cloud platform, particularly strong points around data sovereignty, around the strength of the network underpinning the IBM Cloud environment, and the security play that's so strong with the IBM stack. A lot of what we liked around the IBM story as well is things like the bare metal performance, and a lot of different services that we felt the other cloud providers just weren't quite there with. And the thing we love most of all is the financial planning element of how we can put together a managed service for IBM. So the idea with this session is, and to try and demonstrate for other things, is that a partner like ourselves, and why IBM have brought us into this mix of a number of years ago, is that we're the primary route to market for their cloud platform and services. Like I said, we're one of the leading partners in the Irish market at this point. IBM have worked with us because of our experience of actual delivering these solutions in the real world, whether it's mature VMware estates or legacy applications of one kind or another, and now Power Systems. These are the hard jobs, the ones that don't necessarily lend themselves easily to the cloud, and that's where we're trying to go next. Like I said, we've a lot of deep experience of actually migrating entire businesses in some cases, or else selected applications and workloads into the cloud. The model biz that IBM is a very, very large company with an awful lot of different departments and skills, and it can be hard for customers, particularly smaller ones, to know where to start. So again, like as in always, the idea is that we're a point of contact of account management. We can give you the access to the relevant people within IBM's vast portfolio of services and products, and be your advisor and your guide and your day-to-day liaison. And we bring the right resources from IBM into the picture as necessary. So it's a really good team, and it's a good team service you get. For a lot of partners, the Power Systems present a bit of a problem as well because of the skill shortages in the market, and a lot of customers have either removed power systems or are considering what the future of them is. And one of the big issues there, of course, has been skills and availability. So our whole approach is to offer our cloud services with power systems as a managed service, so you don't have infrastructure skills to worry about anymore. You don't have to think about management the same way you did before. So it's a controlled managed service environment with security by design, and that's the key kind of message really. So if you're wondering, well, where do these guys fit into the mix, that's exactly the idea. And again, like, we have a very, very strong skills matrix at this point between our internal skills and a vast network of contractors and third parties. We can pretty much put any kind of technical solution in place together, and obviously IBM is one of our partners as well. But regardless of whether people are on legacy power systems, often back to even Power 7, which is still very common in the market, we have a solution to work with you between IBM directly and ourselves and IBM's partner ecosystem. And that's the real true strength of this whole approach. So the idea is that everybody can get into the cloud no matter what generation of power systems you're using. So that's really the quick introduction to DNA. That's why we're here, and we've pulled this together to try and, I guess, create hopefully something that we'll do more regularly to keep the market up to date with what's going on. So to kick off the next step, I'm going to hand you over now to David Spurway from IBM, and David is going to walk you through some of the new developments around Power 10 and some very interesting new features and developments there that I think everyone will be interested to see. So over to yourself, David.
Wonderful, and I'm showing the wrong screen, aren't I? So let me just swap those around again. Hello there, yes, I'm David. Is that looking better?
Perfect, off you go, yeah, that's great.
So hello there, yeah, I'm David Spurway. As introduced, I am a systems technology architect inside of IBM, and I've been working with Power Systems for many years. And so I wanted to take you through a few slides talking about to the power of 10. As hopefully you're aware, but in case you're not, we've recently announced the latest generation of IBM Power Systems that's based around the processor that is called Power 10. So we have some new toys in the market that bring the ability to do some new cool things. And of course, that also is talking to the cloud discussion that we were just having. So what I want to take you through briefly in my part is what is Power 10 all about, and Power 10 is all about responding faster to business demands, which of course is very much the kind of reason that people are looking to cloud technologies and moving forward to enable that agility. You want to be able to, while doing that, protect your data from core to cloud, so we need to be able to make sure that your data is safe, that is encrypted, to be able to avoid those sort of bad actors, but also against any kind of other issues that might occur from a kind of point of view that can be exposed. We want to be able to get new answers out of our data. We want to be able to streamline insights and automation, so we can actually make the actual management of our systems easier with automation, and also be able to get new answers out of that data moving forward as well. We want to be able to maximize the availability and reliability, as Power Systems has a very reasonable and justified sort of view from the market as being a very, very reliable system indeed, to be able to build your business upon. And of course, that's why customers have been using it for so many years, to be able to be the core of their business processes moving forward. We also, of course, it's increasingly important with the COP26 just winding up in Glasgow, my hometown, that the sustainability of the solution is something we're getting asked more and more all the time. And so we've got a good story about sustainability, so we can talk to that piece as well, as we can do more with our newest servers with less energy. And so that's all good as well. As I say, when responding fastest to business demands is something people are using the hybrid cloud approach to be able to achieve. You can use elements that are going to be in your prem. You can use elements that might be, for example, in a partner's prem, such as DNA. You could also, of course, use the kind of examples which are outside, are no longer on your prem, but actually using maybe ones that are co-located in IBM's cloud or other clouds. So you want to be able to also automate that, as I say, reliable automation with Ansible, which can be done across any of these particular usage patterns. You could do that for the on-prem systems, you could do that for the off, but again, getting reliable answers, getting reliable systems that work exactly as you're expecting them to, time and again, as you repeat steps, and automation makes that so much easier to do than relying on manual systems. We can also deliver the economic and compute flexibility. We can do that with an offering we call IBM Power Private Cloud. That's the offering that could exist either in your prem, or it could be the sort of thing which is used in a partner's premises. We've seen that quite done very often, This allows you to get to the point of being able to do pay as you go without necessarily having to move the entirety of his business away into somebody else's data center. Of course, as I mentioned, this could be in your data center, it could be in a partner's data center, it can be done a variety of ways, but you can get all the way down to paying per minute as you move forward, and giving you the cloud benefit of pay as you go without necessarily losing control. Other elements, you may want to move the entire system out of your data center, depending on what your use case is. You might want to move parts of the solution out of your data center, and that's what we can do with IBM Power Virtual Server. It delivers the benefits of IBM Power, all that performance, all that reliability, with the ability to be able to do that from IBM Cloud. Jim will be able to talk more about that a little bit later on, and I'll also mention more about it in the deck as we move on. So that's what I want to take you through. I won't take too long doing it, so as usual. So this is the kind of core piece that we talk to about what actually IBM Power is all about these days, what particularly the current versions are talking to. So IBM Power is engineered for agility. So that modernizes with a frictionless hybrid cloud experience. So you can do cloud on-prem, you can do cloud off-prem. You can also potentially pay one particular cost up front. I'll talk to that later on the deck. You can sort of decide how you want to actually sink your money and invest, and then decide where you want to deploy that. You can deploy that in the cloud from IBM. You could deploy that actually on-prem as you move forward, on demand as you move forward. And that's what that hybrid cloud experience is talking about. We want to be able to respond fastest to business demands. So we want to be able to do that efficient scaling. You want to be able to do pay for use. We can do that in the public or private clouds, as I talk about. And of course, just the pure performance of Power, being able to go so very, very fast, means you can also get fastest answers out of that as well. What also we're talking to is that we can also do other pieces, which I'll add about AI, which I'll talk to in just a second. While moving at this kind of pace, you also want to be able to make sure you're safe doing so. So you want to be able to protect your data from core to cloud. We can now, if you wish to, use actually memory encryption. The actual memory in the server can be encrypted and used and worked upon while it's still encrypted, so that if you had any kind of issue, such as the sorts of things that we saw turn up in the Spectre meltdown kind of world in the past, that's the memory encryption is one kind of area that can help cover that kind of process. So even actually right up at that memory and in-flight data, you can keep it encrypted, keep it safe, all the way through to we're actually using things in the file systems, and also on out to the data that's actually sent to the cloud. All of that can be encrypted end to end to make sure that you're safe and secure and know that nobody can access your data when you don't want them to. And also, as I say, we can do streamlining and insights and automation. So I'll talk a little bit to Ansible and how we do automation a little bit later on. We can also stream insights in that we can actually do AI directly on the systems themselves. So you can work with the data in flight as it comes into your systems. The absolute most cutting edge, up-to-date version of the data could have AI inference or AI machine learning models run against that without having to copy it elsewhere. You can, of course, also take copies and use it elsewhere if you want to, but if you wanted to be able to do things right on the systems, we've now got elements inside the Power 10 processors that offload the work and the effort, both to encrypt the data and also do this AI so that it doesn't attract software costs. Obviously, we can also reach out to the IBM Cloud, do the hybrid cloud approach that we know is so popular with customers, and for good reason, to be able to use Watson services and beyond as well. We do all this while maximizing availability. We want to make sure that we look for and rule out and minimize any kind of areas that might give you a planned outage as well as an unplanned outage. We want to find areas that might have caused problems for customers in the past, maybe with unplanned outages. Thankfully, they're fairly uncommon with Power Systems, very reliable building block in the first place. We also know customers can have outages when they need to do maintenance on the systems or other elements like that. So we continually look for both, minimize and where possible avoid any kind of issues which will involve any outage of that nature, and so we can maximize your availability and reliability. And we look to things like how we use memory as one example of how we do that within Power 10. And as I say, with the background of COP just winding up and the progress we're making there, we also want to make sure we can do this sustainably. So we want to be able to do more with less. We want to use less materials for how we ship the servers or how we make the servers. We want to be able to use less energy and space when we're actually working these boxes. And all of this can actually be done potentially at the same time as lowering cost. So to give you a little bit more on that and how that works, we've got the Power 10 sustainability compute. We've been using power processors after all over 30 years, gradually improving over that time, improving the system performance all the time. And the performance can come up, and that means you can do more with less. And if you use less processors, that of course gives you energy efficiency. We're also now, with the most recent generations of systems with the Power 10 boxes, you can do that even better. For the IBM has a point of view. You can certainly contact me to learn more about it, or check out the LinkedIn posts I've been putting out about how this works. So we can actually talk to, if you actually are using more current infrastructure components, those will be more efficient as we move forward with the technology. You can also be looking to use performant and scalable infrastructure, and through that you can use virtualization to consolidate your workloads together. If you're doing all that, and that's of course how the clouds do it too, then you can end up driving higher utilization. High levels of utilization means you need fewer processors and fewer compute resources, which means you can actually be more energy efficient at the same time. As I say, Power 10's got a very good story here. So we've been able to deliver so half we can do the same kind of workloads as a big full Power 8 system can actually be handled in about half the size in an E1080, and that means we can use about half the energy to deliver the same performance. So we're able to do impressive jumps over Power 8, even on the Power 9 boxes, which are very, very scalable and very, very performant. We can also use less energy than those as well as we gradually move forward. Just to mention, that's not where Intel is. Intel actually are coming out with newer processors with slightly faster processors, but it takes more energy in those to be able to deliver that performance. And with Power 10, we saw this coming, and we're able to actually enable these to be able to do the same performance or more with less energy. So here are kind of high-level numbers on the Power 10 world. We're able to, as I'd say, we're looking to be able to make sure we maximize that availability, maximize reliability. So inside of our memory, we can actually make sure that we're using IS DIMMs, industry standard DIMMs, but use them in such a way as to be able to give you double the level of reliability on that memory inside the Power 10 box as we move forward. As the memory gets bigger and bigger, you need more DIMMs, and therefore if you can make them more reliable, that minimizes the chances of an unplanned outage. We can also be very, very performant. We've got some benchmarks that out there that aren't just IBM saying so, but people like SAP saying so, how very, very fast these things are. You can modernize with the worlds of containers, being able to do up to 4 times or more per containers per core than x86. If you're using the worlds of OpenShift, for example, then that software can often be charged by the processor core. So being able to have such a high container density can save you considerable amounts of money. We are able to encrypt your data. We're able to do that from core to cloud. We've got engines inside the Power 10 processors that offload the effort. So maybe you weren't using some of the encryption capabilities that you had available to you before because you didn't want to end up driving up software costs through doing encryption. Well, that's all right now because we have the ability to offload that work within engines inside the cores to be able to move forward and also be able to do it faster than we ever did before. And we're also able to do AI, as I mentioned, directly on the processors, very, very fast indeed, being able to do AI inference directly on the data itself. And as I mentioned, all of this with a sustainable message at the same time, having more capacity and the same energy consumption to be able to move things forward. So there's lots of words here, and I'm not going to sort of batter you with all of this. The big E1080 might not be the kind of scale of server that everyone on the audience is interested in, but there's some key messages to this. So it's a follow-on to Power 9, and so one thing you can take this, of course, is we have a strong, sustained roadmap. We're already working out what we're going to be able to do with the Power 11 processors. We're already thinking of those. We know who's going to be making them as well. We're partnered with Samsung to be able to work with that, so we've got a strong roadmap for Power to be able to move forward. These are built in a similar sort of modular design as we did before. They can go very, very large. We can go all the way up to 240 cores with all of the ability to be able to do all of those cores running 8 threads at the same time. If you'd like that kind of package, do let me know, as we can actually get extremely big and large if needed. We can also keep those enormous numbers of cores very well fed with data, as we can actually move the data around inside these systems and also concurrently maintain it so we don't have outages. We can be secure and reliable with what we're working with, and know that if anyone's been tampering with any of the boot images, we can react to that, avoid that, and make sure we don't have any problems. We can control it all from a single unit. We can also get very, very large with memory, and as mentioned, that memory is also built to be reliable. Huge amounts of memory bandwidth. So if you're looking at SAP, for example, the memory bandwidth we can do here is the sorts of things that allow in-memory databases to absolutely fly. We can also encrypt that data and work with it while it is encrypted. I mentioned that earlier. And we also have future potential to be able to use memory in new ways with a cool new offering called Memory Inception, which we'll talk more about next year. We are also doing future proofing here as well in the form of the I/O. So we were able to keep the performance on the processors, the very high memory bandwidth, and also the I/O to be able to get the data in and out, ready for Gen 5 as those come out. And so as new generations of adapters turn up, we'll be able to use them in the system. Very high performance net disks to be able to boot the box as well, and we can get even bigger if we need to, depending what you're after. But as I say, I think there are a couple of just key points: really fast processors and lots of them, very, very high memory bandwidth, and also the I/O can go furiously fast as well. If you want to know more about that kind of whole world, do let me know. I mentioned the fact that we are responding faster to business needs, and of course we're talking about hybrid cloud, so let me move to that piece. So we can do cloud power boxes in a variety of different ways. We can do them as standalone servers, absolutely valid use case. We're doing that all the time with many of our customers. We're also able to do cloud with the ability to do the Power Private Cloud, and I'll expand a bit more about what that is in a second, but that allows you to be able to do dynamic capacity, pay by the minute for what you're actually using over and above the kind of piece you've paid for already. So we can do cloud on-prem. We can also do cloud by using Power Systems Virtual Server, which again I'll expand on in just a second, but that's the offering that sits co-located with IBM Cloud. And all of these offerings, all of this for AIX, IBMi, Linux, OpenShift, standalone, Power Private Cloud, Power Virtual Server, all of these can be automated with Red Hat Ansible. Red Hat Ansible, to be able to expand a bit more about that, it's the ability to be able to use existing apps and emerging apps with OpenShift. We can actually do this on-prem or off-prem, and what we're able to do is be able to actually automate that using the Power Private Cloud, maybe using IBMi, for example. You can use endpoints with IBMi, which of course is a very common solution we run on power boxes, and this doesn't have to be a chargeable process. You can get content from the community, and that you can use IBMi for that, and also you can get that from for Linux as well. You can also, if you want to, depending on what your demands are, you can also get that actually from a sort of paid content within Red Hat as well, depending what you're after. We can use this within the Power Virtual Server and the IBM Cloud. We can also use this for SAP HANA as well, and we can actually do, as I say, that management of AIX and IBMi, modernize the AIX and IBMi alongside modernizing with containerized apps at the same time. So to give you a little piece about how the Power Private Cloud works, most customers are wanting to do some level of modernization. They may have older boxes. There was mentioned earlier on that people are actually talking about the Power 7 systems, for example. We might want to be able to modernize those. We also all normally want to be able to save money at the same time. But the two can be quite hard to achieve, but that's exactly what Power Private Cloud is designed to do. So here you can take a couple, 2 boxes or more, group them together, have a certain amount that you've actually paid for as a capacity, which you know you've used, and therefore you don't need to pay any further for. And you then also have the ability, if you start using these more heavily, if you move the workloads around within the systems, you don't need to pay for any more. But if you start using up the workloads beyond what you started with, you can monitor this with a solution that runs out of IBM Cloud called Cloud Management Console, and then pay by the minute for any workloads any utilization that comes above that. So huge amounts of flexibility, being able to deliver customers the ability to instantly and dynamically respond to changing business needs, combining flexibility and agility with security, resilience, and performance. You can get extreme economic efficiency, so we can actually pay for just a tiny number of processor cores and then be able to move everything into OpEx if you want to do that. We're also able to make sure that we do that per minute, as I mentioned earlier, and so lots of efficiencies in the economic side. That's what allows you to do that dynamic responses and to changing business needs, and it's all graphically monitored and planned as you move forward. So maybe you have varying workloads, and this might be useful to you. Maybe you are like DNA, a service provider, and you can pay-as-you-go might work for you. As I say, this could be deployed on your premises, it could be deployed in partners' premises, wherever you might be looking to. Maybe you've got older IBM Power Systems, maybe CapEx issues held you back before. Let us know if you want to know more, because there's plenty we can do in this space. That was the offering that can be in your prem or the partner's prem, and then Power Virtual Server, the IBM Power Virtual Server is the offering that can do in IBM Cloud. So you can, as a user, purchase a virtual machine as a service, AIX, IBMi, or Linux. Any of these elements can be done. Your users can purchase that. You can use this, buy this on a consumption-based plan through the IBM Cloud catalog, and they're available worldwide. We've got 2 DCs in the London area. You've also got the ability to buy them out of Frankfurt if you want to be be able to have another location in Europe, and of course available in a variety of different locations all around the world as well. IBM manages the deployment of the OS, so we can deploy IBMi, for example, and then somebody, be that yourselves or maybe a partner like DNA, can then do the management of the OS and up on that offering. They run on Power boxes, so they are running the same Power systems, the same Power 9 systems today, and Power 10 in the future, offerings that you might choose to deploy on your prem. So very valid test pace, therefore. If you want to know more about the Power 10 boxes when they turn up in the cloud, you could try it out there before moving them onto on-prem, depending what you're after. You can be very, very precise about this. So you can be very, very detailed about the amount of cores you're actually purchasing. You can change it as well. So you can start off with a quarter of a core and grow. You can use shared and dedicated options. And as I mentioned, we have announced a statement of direction that we will be seeing Power 10 rolled into these elements. Power 10 will turn up in the IBM Cloud in the Power Virtual Servers moving forward. They're also hugely flexible, so what we can do is we can resize things. So this is something where you can start off with maybe 2 processor cores. You can actually grow that up to the kind of realm of 16. You can bring that all the way down to a quarter. You can flex back and forth in all that kind of way dynamically. You can actually do all of that while the system's up and running. So if you imagine a kind of situation where you have a system in the IBM Cloud maybe providing a DR service, you can start off as tied down, as minimized as much as you need to be able to keep it ticking over, and therefore of course you minimize your costs. And then should you need to invoke that, you can dynamically fire it up, dynamically make it grow, ready to run that system in the kind of DR sense should you need to do so. And that's not the same as how other clouds work. So for example, in AWS here, what steps do I need to take before changing the instance type? Then you actually need to stop it. You just stop it and need to make changes to it and then restart it. But with our offering, you don't have to. You can do everything dynamically and move forward. So the Power Virtual Server, in my view, is more dynamic and more cloud-like than some of our competing clouds might be. And just to finish up, you have also the ability, it's a statement of direction at the moment. We do this already for a couple of customers in the US, but if you're interested in doing some of these pieces, you could, as an option, buy hybrid capacity credits for Power. You purchase these credits, and then it's up to you where you deploy them. You could deploy them in the IBM Cloud in Power Virtual Server. You could use the same credits and use them up using the Power Private Cloud. So you can actually decide where you want to put these things, and they don't have to be located in any particular location. Again, very OpEx style, burn it as you like and see where you end up going. So that wraps up my piece. So I'm happy to take questions as we move into that section later on in the agenda. But what I wanted to take you through was Power 10 is all about responding faster to business demands, protecting data from core to cloud, streamlining insights and automation, maximizing availability and reliability, and also doing so at the same time as being sustainable compute as well. And you can respond faster to business demands with hybrid cloud, enabling that automation with Ansible, economic and compute flexibility with IBM Power Private Cloud, and also IBM Power Virtual Server delivers the benefits of IBM Power with the IBM Cloud. And with that, if I can hand back to you, sir.
Thank you very much, David. That was fantastic tour de force on Power 10. Thank you very much. Okay, so I'm going to move us on now to another presenter, James McKay from IBM. James, you should be seeing this come up now. James is going to give us a little look at some of the use cases for Power in the cloud, such as backup, disaster recovery, and a little bit more on Power Virtual Server. Okay, take it away there, James.
Thanks, and thanks, David. Thanks, Adrian. So yeah, it was really just to focus in a little bit on particular use cases for Power, and a question that we often get asked is around, that's great, I can use Power in the cloud, but how resilient is that, and how can I use that to increase my current kind of resiliency posture? So I just wanted to kind of focus in on that area in particular. And if I just go through first of all the kind of DR aspect, and just from a very high level, we see two kind of very common scenarios. The scenario on the left is where we have a customer on premise. They maybe either don't have a full DR. They may be using kind of backup as a DR mechanism, and they want to either increase the kind of availability that they have, or they maybe have DR currently, but they're looking to kind of consolidate data centers, and so their DR data center, they want to move out of that and look for an alternative. So basically, in this scenario, we're using the cloud as the DR location and connecting up on-premise environments with the cloud. And so we can do that both for IBMi and AIX, basically any power type workload. We can, with secure connections, have private links going from on-premise to cloud, IBM Cloud. That can be, over the public network using virtual VPNs, or we can, establish direct MPLS type connectivity directly into IBM Cloud. And obviously, we have cloud locations, as David mentioned earlier, across the world globally. We have it in Frankfurt in the EU region, and we have it in London. And each of these locations have multiple data centers. We talk of a region comprising kind of multiple data centers. In each of those locations, there'll be at least 2 data centers with the Power Virtual Server offering available. So that enables the ability to kind of replicate into the cloud. For IBMi, we recommend the geo mirroring with Power HA clustering, and for AIX it uses GLVM, so OS-based level mirroring. The other scenario is, sometimes clients look at that initially. That's an initial workload to move in to utilize cloud as kind of the DR environment. But also that can be used as a migration strategy as well, to start replication into the cloud and then essentially failover into the cloud so that it takes over the primary workload. And so once you're in the cloud, there's also, like I mentioned, because we have multiple data centers, the ability to move to the scenario on the right-hand side, which is high availability DR in the cloud. So this is where we're using multiple zones or data centers in a region to have that level of resiliency. So it's doing replication between those data centers, and with those being, either in region, so we can do replication either, for example, in Frankfurt, between Frankfurt data centers, or we could replicate between London and Frankfurt. It's asynchronous replication, so that can stretch. When we close the distance, obviously that level of asynchronous replication becomes tighter. So with data centers in a particular region, we're looking at sub 2 millisecond latency. So that allows for very, very fast replication, almost synchronous, but it is tied as async replication. And again, it's the same technologies. So GLVM for AIX and GeoMirror for IBMi. So if I move on, the other typical scenario is kind of the backup aspect. So maybe not requiring full DR, or maybe to supplement a DR capability is the ability to do backups. And again, this is where we can utilize other cloud, IBM Cloud offerings. So we have IBM Cloud Object Store. So object storage is very expandable. It's got multiple tiers of kind of storage that you can utilize, all the way to very cold kind of archival. It can do things like write once for any type of compliance recording of data, so that it's basically immutable. So it's very good as a backup target, and there's a number of ways of utilizing that, either directly from the IBMi instance, or using backup tools like Spectrum Protect that we can deploy in the cloud, or other third-party tools like Veeam, to be able to use that object storage in the cloud as a backup target. And that can be done both if it's an environment on-prem, so within your existing environment, use the cloud as the backup destination. Or once you're in the cloud, if you want that kind of resilience, maybe running a single location, you can back up your data to that object storage. And object storage can be deployed. You can utilize that where it's highly resilient across multiple data centers within a region. So it's basically got that level of resilience already built into it. It's not something you need to worry about. You just utilize it as a service. That's all metered purely on the amount of data that you're actually sending. So you don't need to provision storage up front. Object storage is metered on the amount that you're actually using, and it can scale to huge volumes. You can also do things like set expiration times, so you only keep things for a certain amount of certain period of time, and then it will auto delete. And as David was mentioning, we've got lots of encryption all around all of these things. I should mention that in the cloud, a lot of people think of it as being, well, I'm putting things up essentially onto the internet, and it's really not the case. It's much better to think of the IBM Cloud as a private data center area that you can utilize. Yes, you have the ability to put those systems to connect them onto the public internet, but equally they can all be configured purely on a private network basis with secure links directly down to your premise, whether that's other office buildings or other data centers. So we can deploy these in a very highly secure manner. And that goes the same for any of these other services. They can be deployed in that manner. And so I just wanted to mention, there are then at the application type level, as we move into things like databases, they can also take advantage of that private networking in the cloud. So, I mentioned multiple data centers. We have a global private backbone between all of those data centers. So any of that replication traffic, either GLVM or application replication, is all going over private links. So it's all secure and isolated. And so you can take advantage of that, not just for underlying replication, but application level and database level replication. So there's fully supported solutions like Oracle DataGuard, DR solution, DB2, DR implementations, or SAP HANA replication. So all of these kind of use cases and many more, obviously, can be deployed in the cloud. And some of these, because of the the latencies that I was talking about, if it's between zones within a region, you can actually achieve synchronous replication. If they're spread out kind of geographically, spread out broader, so between regions, as we would term it, then that moves to more kind of asynchronous type replication implementations. So that was, I think that was it in terms of the main kind of use cases. I do have a number of diagrams that kind of go into the architecture of how this is deployed in the cloud and how we can connect it into other workloads that you have running on the cloud, whether they're data and AI or just other x86 environments. Very often clients have a mix of kind of workloads. And again, one of the benefits of moving this into a cloud that has both Power and x86 is the ability to move those workloads together, so that they can still all operate within a private environment in the cloud. But I just wanted to move on very quickly just to kind of give an example and show a demonstration kind of the cloud. This is our standard portal, so it's cloud.ibm.com. If you have a cloud kind of standard account, this is where we log in to orchestrate all of the cloud resources. This is my test account, so I've got a number of resources deployed here. If I search on the resource lists that I have, if I type in Power, you'll see a lot of Power instances. So you can think of these as a logical isolated network grouping of Power systems. So this could be test dev, production, pre-production, or DR. This is just a way of logically grouping your systems in the cloud, and it is by data center location. So I've got these in London, Frankfurt, Dallas. If I go into one of these, this is then going to bring up the instances that I have deployed in that logical grouping. So it will list out the servers. You can see I've got 6 servers here. The naming isn't very inspired, but as David mentioned earlier on, these can be, quite small instances, and you only need to, you can deploy small and then grow that over time. So these, the scaling kind of granularity is 0.25 of a core. And we can also do things like dedicated cores if there's requirements for licensing or those types of things. So there's lots of options around this, but I just did want to kind of bring out a couple of aspects of this. Before going in and kind of showing one of these instances, one of the easiest ways to actually migrate into the cloud, we obviously have standard AIX and IBMi images available to spin up, and then you could deploy your applications on top. But if you actually wanted to migrate an image into the cloud, we actually have this capability for boot images. These are all the images that I've created or I've used. Some of these are standard images, but we have the ability here to import an image. And if I just click on that, I'm not going to go through all of these details, but basically this uses the same object storage that I talked about for backup. It uses as the mechanism to transfer images into the Power environment. So I can select the region that my object storage is in. I need to give it some details around the object store, the security, encryption keys around that, the level of storage performance that I want associated with that image. So we've kind of got 2 tiers of storage performance in general, 3 IOPS per gigabyte or 10 IOPS. These are basically kind of SSD performance, or tier 1's actually NVMe. So these are very highly performant storage capabilities. You import that image, and then that image will just come up in your boot image library. And these can be multiple volumes. This could be an entire server workload, but it's really that simple. You create the image on-prem using Power VC, create the OVA, import it, and it will show up here on the image list. And from here, we can then directly deploy that as a server instance. The other way is to create an image using MakesSB. Again, this is something partners will often do for clients to assist them. Another way of capturing the image, again, that can be imported in this manner. And once you have that, you can then just create the image, create the actual server running in the cloud from that boot image. So it will just show up as one that you've imported. You can see here I've got standard images, and then there's a bunch that I've created that you can build the system from. So that's a very kind of quick introductory way for a migration. Obviously for things like DR, for backup servers, they can all utilize this same underlying infrastructure in a similar way. Create the images, set up the replication, and that's basically it. There is the connectivity, and as I mentioned, there's lots of options around that. The beauty of having this all available through IBM Cloud is that there are multiple connectivity options around VPNs, direct MPLS connections. However secure and isolated you want it to be, we have options for that. And while you build all of this, as David mentioned, this is all metered on a minute or hourly basis. And so, it's constantly providing kind of cost estimates as to what this will actually charge if you deploy. The beauty of it being, again, as David mentioned, around automation with Ansible, this can be all spun up programmatically. So if it was, another use case of DR needing to scale the systems, that can be done automatically through automation to dynamically increase the systems, or actually create entire environments so that you can recover maybe from backup or those types of things. You can quickly spin up environments programmatically, have templates of the servers that you require. It will spin them up and deploy. You can then start to recover the backups onto them. So that covered it in terms of kind of the broad demonstration and just topics I want to cover in terms of DR. Not sure if we've had any questions come through, but did want to leave some time in case there were any.
Yeah, thanks very much, James. That's excellent. Yeah, we do have a couple of quick questions we have time for. We have a couple of questions that have just come in, and I put this open to the panel really as much as yourself. So James, David, Noel, we have on this whole topic, I suppose, what about questions? We have a couple. There's a question, what about the older versions of Power? Customers using the older versions of Power, where are they in all of this? If you're using Power 7, Power 8, who'd like to take that?
Do you want me to try and start with that? So what's important, after all, if we're going to be moving forward into the kind of the Power Virtual Server we just talked about, is the version of the operating system you're running upon. So of course, you could have we certainly have customers, like you say, running some of the older forms of the Power Boxes, maybe the Power 7s, maybe others. Those are capable, of course, of running more modern versions of the operating system. And so as long as your operating system is relatively current, you can still take advantage of these offerings. So in the AIX world, you want to be in the kind of AIX 7.1, 7.2 kind of world, and of course we have 7.3 coming out as well now, recently announced. And so it's the operating system level that's important there to be able to make use of the mixSP process that Jim talked to. In the IBMi case, we actually do have the ability to be able to go back quite a long way. So if customers are running IBMi even all the way back to 7.1, we've now got 7.4 after all is where we're currently at. So 7.1, 7.2, 7.3, or 7.4, any of those instances of IBMi could be moved up into Power Virtual Server and be fully supported in that environment.
Okay, very good. We have another question, just I suppose in terms of production systems. Someone simply asks, are they there yet? Are we at a position yet where we can run production systems in the cloud?
I've got a thought, but Jim, do you want to say something? Do you want to take that one?
Yeah, I mean, it's a question that we do get asked, and we've got many customers running production in using this service and using other services in the cloud. So absolutely, we absolutely stand behind this being kind of production ready. We do have service levels associated with cloud in general. They vary in terms of if it's a single data center implementation, it's 3.9. SLA, if it goes to multiple data centers, we stand behind a higher SLA up to 4.9s. So we do even contractually have confidence in this on the platform. But I think it's also the range of kind of deployment options and the wealth of kind of different capabilities there to increase the resiliency, and that's where technologies like the DR capability in the cloud are utilized for the most critical workloads, whether that's an application kind of database level, or whether you use some of the underlying replication technologies. So yes, absolutely, it's ready for production. We've got many clients running production workloads on the cloud.
Okay. Someone else asks, the data centers that run the Power systems, the Power Cloud environments, where are they located?
Yes, I think we touched on that. So we have, in terms of Europe, we have Frankfurt as one region, and again, mentioning region as a minimum that have the Power servers. So we have Frankfurt and we have London. Then, going out geographically, we have it basically in every major continent. So US, Asia Pacific, we have multiple locations. So, Japan, Australia, North America, Toronto, I should say USA and Canada. So yeah, we've got broad geographic coverage, and another key aspect, like I think I mentioned, was the the global connectivity between all of those data centers. So the ability to do that replication traffic in the cloud on private secure links is another another key thing.
Okay, very good. There's a question with regard to
just popped one of the case studies into the chat, just so that we can always share the link elsewhere as well. So we got some major customers such as Coca-Cola Europe is the sorts of people that are using Power Virtual Server live today.
Excellent, very good. Thanks for that, David. Yeah, it's very useful. I suppose it does tie into another question someone has asked with regard to financial sort of planning and modeling for running a production system. Is there the ability to sort of run the numbers and do a feasibility and on the costs the way there is with other systems, is in terms of pricing and pricing up a power system in the cloud?
Yeah, so I mean, pricing is very transparent. We have that, publicly available. Again, this is where partners often help to build that pricing model, because it is basically a catalog type, offering, where there's lots of different options, lots of different elements to potentially bring together. But in terms of the pricing, it's all publicly available. So it's getting pricing for all of the elements is very straightforward. We also have pricing configurators on the cloud, where you can kind of build almost that kind of shopping list of elements. But very often we find that partners assist clients in putting all those kind of jigsaw pieces together and building that total cost in the cloud.
Yeah, well, absolutely. I'd comment myself. We've seen that our role has proven to be that a lot of the time we're very much depending on what every customer situation is. Our role, we see it as being the go-between at times to get the best mix of the IBM technologies and platforms out there. And I have to comment, I suppose, at this stage, I'd like to say as well that in our own experience, we have found a real strong value here for our customers in the real world is the IBM partner ecosystem is very, very strong in terms of resources and expertise of every kind. We've had to reach into that ourselves at times, and it's proven to be very, very powerful. So I think that's a really good story, and for us, it's very reassuring that there's a lot of expertise in the wider global ecosystem, and there's a lot of cooperation as well, so that customers have a very strong network there of support. It's very, very strong. So for us, that's been very encouraging as well, I must say. We don't really have any other questions, guys. There was a comment made, I suppose, with regard to services in the Irish sense. I think we've answered that. I don't think there's any limitations on customers in Ireland on any of this. It doesn't really matter where you are. Is that a fair comment?
Yep, that's a fair comment, Adrian. It's Noel here. Absolutely, that there's no lack of services available in the local market. In fact, I've personally worked with Jim and Dave on it with customers in the local market, and as resources, we're all available to DNA, and happy to work with DNA and the depth of services that they have. I just wanted to make one point myself, Adrian, and thanks very much for putting on this webinar. My real concern for power users at the moment is, in a lot of cases, the lack of what I put in inverted commas a proper DR strategy. Because it's a massive capex outlay. Obviously, if you're going to mirror systems in different locations in power up to this, I think what we have now is the opportunity to put proper DR solutions in place, not a second Power in the same box, but a proper DR solution up in the cloud, which becomes an OpEx and is managed for you with several tests a year in the sort of service that you'll be offering. And I think that's really needed in the marketplace, and it's great to see DNA delivering this into the Irish marketplace now.
Yeah, absolutely. It's something we've definitely seen some strong interest in, and I guess we see it as it makes sense, and it's when it's managed and the customer doesn't have to have the extra headache of skills and all the rest of it. So it makes a lot of sense. So listen, guys, that's all the questions, and thanks very much for joining us this morning, guys, as a panel. I know you're all extremely busy. That's really, really good content. Everyone who's attended, I hope that was useful. If you're listening back to this later on, again, there'll be some notes accompanying this as a video where you'll see it on YouTube and on our website. Please do get in touch with any of us here. I'll have my contact details on the end of this as well. Any queries or questions, or if you'd like to have a deep dive with James or David or any of the team here, just let us know and we'll arrange that for you gladly. So thanks very much for your time, everybody, and we'll talk to you soon.